Now this is the last part of the proof of Euclid Book 2 proposition number 11. And I know that this diagram is not Euclid Book 2 proposition 11. It is actually the diagram of Euclid Book 2 proposition number 4. Now, what you've been studying all along has been quadratic equations. And I'm going to prove this to you in just a second. If you will go back through Euclid Book 2 propositions 1 all the way through to 11, you're going to see various demonstrations of the quadratic formula. But in Book 2 proposition 11, it becomes very apparent. Okay? It was kind of alluded to in the previous proofs, but in proposition 11, it was directly stated. Okay, and here's what we're going to do. We're going to take you through Euclid Book 2 proposition number 4 to kind of show you how the quadratic formula was alluded. Alright, let's take a look at line AB. You have a line A to B right here. And it is the sum of lines AC and CB. In other words, the length of AC plus the length of CB is the length of AB. Now, the square of AB, okay, this is the square of AB, is the sum of the squares of AC, which it's this square right here, but we'd have to move it up here in order to show you that this square right here is the square of AC, plus the square of CB, which is this square right here, plus twice this. Okay, so this is twice the rectangle. Thus giving you, because what we're going to do in this equation here is we're going to represent x as AB, y as line AC, and z, and I'm going to take this right over here, x as AB, y as AC, and z as CB. So, what we end up with is an equation that says x squared equals y squared plus z squared plus 2yz. And I think you can recognize this as a quadratic equation. Alright, now, it gets a little more sophisticated when you go to Euclid Book 2 proposition number 5. I want you to draw out Euclid Book 2 proposition 5 right now. Pause this video, draw it out, and then I will discuss it with you. 1, 2, 3, 4, 5. Okay, now we're back. Now then, we're going to represent, now don't look at this diagram here, because this is not the diagram for Euclid Book 2 proposition number 5. You've already got it drawn out. Okay? Or if you don't, you should have by now, because I told you to pause the video and do it. Alright. In that proposition, line AD is going to equal the letter A. Line BD is going to equal the letter B. Line CB is going to equal A plus B divided by 2. And here's how that works. If you were to add line AD and BD together, you would get and divide it by 2, because see, line AD plus BD in that proposition became line AB. And if you take line AB and divide it by 2, you get line CB. Alright? Now, what about line CD? How do we represent it as A minus B divided by 2? Well, keep in mind that if you were to add line AC and CD together, you would get line AD. Also keep in mind that AC is equal to CB. Okay? And we already know that line CB minus DB equals CD. So therefore, if you were to take line AD and subtract line BD from it, then divide that number by 2, you would get the line CD. So, here's what you have in the line of a quadratic equation based on what I've just told you. And I hope you wrote all of this down. Okay? And I'm going to take it through one more time just so you get this understood. We're going to represent in this equation line AD with the letter A. Line BD with the letter B. Line CB is going to be represented as A plus B in parentheses divided by 2. And line CD is going to be represented by A minus B in parentheses divided by 2. Okay? And remember, line AC, the length of AC plus the length of CD is the length of AD. And the length of AC and the length of CB are exactly the same size. And the length of CB minus the length of DB equals the length of CD. Okay? So what you're going to have at the end is an equation that reads as follows. A plus B divided by 2 in parentheses, and have that squared, will equal A times B plus, again we're going to put parentheses here, A minus B divided by 2. Okay? Now then, I know that gets kind of long. Oh, and that's squared, by the way. Anyway, let's go to the final equation. And I made this one a little bit bigger. This is from Euclid Book 2, proposition number 11, which we drew out. And hopefully you'll research this in order to find out what I'm talking about here. We have A times A minus X equaling X squared. Now, how did we get all this? Well, we had the length of AB from Euclid Book 2, proposition 11, the length of AB, and it's going to be multiplied by the following result. You're going to put parentheses right here, as you can see here. The length of AB subtracting the length of AH, if you take that times AB, you will get AH squared. Okay? This is the length of AH squared. Now, if you take AB times BH, which BH is the length of AB minus AH, okay? AB times BH, you will get AH squared. Now, if you factor all of this out, see, if you take that A, you multiplied it by A here and X here, what you're going to get is A squared minus AX minus X squared equals 0. And that is a quadratic equation. Okay? But there was something else in Euclid Book 2, proposition 11 that you should have taken notice of. And it's called the golden ratio. Alright. The golden ratio works as follows. You have the length of BH divided by the length of AH, and that total equals the length of AH divided by the length of AB. Let's say that one more time. The length of BH divided by the length of AH, that total equals the length of AH divided by the length of AB. This is the most aesthetically pleasing equation when you're talking about drawing rectangles that you can ever have. And you can do a ton of research on the golden ratio, and I welcome you to do it. But we have just seen an application of the golden ratio in Euclid Book 2, proposition number 11. Now, I know it won't be formally discussed until Euclid Book 5 in the definitions, but you saw an application of the golden ratio in Euclid Book 2, proposition number 11. And that ends the proof of Euclid Book 2, proposition number 11. I will tell you more in a future video, so stay tuned.